Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. I have e to the power x times 2 plus sine 2x the whole divided by 1 plus cos 2x, right? Now what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. I know that my y is not in a very simple format whose antiderivative I know from first principles, but can I use some other trigonometric identities that I already know and simplify this further? So for a minute, I'm not going to touch y. I'm going to see if I can simplify the 2 plus sine 2x the whole divided by 1 plus cos 2x, right? So let me take it out and see what is that simplification that I can do, right? Now I know that my 2 plus sine 2x is nothing but 2 plus 2 sine x cos x, right? So let me write it down. And what is my 1 plus cos 2x? My 1 plus cos 2x is nothing but 1 plus cos square x minus sine square x, which means that I can rewrite this particular expression as 2 cos square x, right? And why is that? Because my 1 minus sine square x is nothing but a cos square x, right? So I can rewrite my denominator as 2 times cos square x, right? So now I notice that I have a 2 in the numerator and I have a 2 in the denominator. Therefore, I can rewrite this entire term post cancelling out that 2 as 1 plus sine x cos x divided by cos square x, right? Now, is there a way I can represent this differently, right? Let's take a look in the next step. My 1 plus sine x cos x divided by cos square x, I'm going to decompose this as 1 by cos square x, which is nothing but a secant square x, plus I have a sine x cos x divided by a cos square x. And what is that? I'll be left with a tan x, right? So the expression what we have is nothing but a tan x plus secant square x, right? Now I go back to my y and you see that we've been able to reduce this to a format e to the power x times f of x plus f dashed of x, right? Why is that? Because my d by dx of tan x is nothing but a secant square x, right? So let me rewrite my y. My y is now integral of e to the power x times secant square x plus tan x dx, right? And now from here on, it is not too difficult because I know that my d by dx of tan x equals secant square x. So the best substitution that I can make is t equals e to the power x times tan x, right? I then differentiate on either side. I get a dt by dx equals, I apply the UV rule, the product rule of differentiation, and I will get e to the power x times secant square x plus e to the power x tan x, right? That's my dt by dx, and therefore, what is my dt? My dt is nothing but e to the power x times secant square x plus tan x dx, right? That's my dt. Now I go back to my y. I notice that my y is now nothing but integral of dt under the substitution t equals e to the power x tan x, right? So integral of dt is nothing but t plus c, and I cannot leave my answer in terms of t. I'll have to put back everything in terms of x, and therefore I get e to the power x times tan x plus c, right? So that's how we go about solving this problem. And let me highlight my final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support